This is section 6.6, part 4. We are looking to solve this equation, and at first it looks like they factored it for you, but you needed a 0 before you factored it, and if I move this over here, I'm going to have a +6 and it's no longer factored. So on this one, you need to distribute. We're going to have to distribute and then refactor. R times R is R squared minus R times 5 is 5R equals -6. Now move this over to here by adding 6 to both sides. And we get R squared minus 5R plus 6 equal to 0. Now we need to factor this. I do not have a GCF. I have 3 terms, and this is a square, but 6 is not. So in this case, I need to find 2 numbers that multiply to a 6, that add to a -5. 1 and 6, 2 and 3. I need to multiply to a positive number, so they both need to be positive or both negative. And this is one where you have to think about, because if you get your signs wrong, you could get a 5 different ways here. If I made one of these negative, if I made the 6 negative, I would get a -5. If I make both of these negative, I get a -5. But only one will work for both. If I make this negative, I will multiply to a -6, and that's not what we want. So -2, -3. So this factors as R minus 2 times R minus 3 equal to 0. Now set each of these equal to 0. Here we need to add 2 to both sides. And here we need to add 3 to both sides. And we get R equals 2, R equals 3. So your 2 answers are 2 and 3. Okay, so let's look at our last problem. 3x cubed minus 48x equals 0. First off, I see a number here, and I see a cube. This tells me I should expect 3 answers. Now, we don't know how to do those in general, which tells me this must have a GCF, and then we get something we can work from there. All right, so I have an x in both of these. I have the 0 already. I have an x in both of these, so I'm going to be able to factor out an x. I really don't want this there, so I'm hoping I can factor out a 3. And 3 does divide evenly into 48. If you remember your division rules, divisibility rules, 4 plus 8 is 12, 3 divides into 12, so 3 divides into 48. So I'm going to factor out a 3x. That gives me x squared minus 16 equals 0. So it's partially factored, but I need to see if this part will factor again. I no longer have a GCF, which is good. That means I pulled the largest thing out here. I have 2 terms with a minus sign in the middle, so I'm hoping this is a difference of squares. This is a perfect square, its square root is x. This is a perfect square, its square root is 4. So I have 3x as a traveler, and x plus 4 times x minus 4 equals 0. Now, the 0 product rule just expands as long as it's a big multiplication problem. And this is, because if I plug in a number for x here and an x here, I would have to do the addition and the subtraction before I multiply. So this is a giant multiplication problem. As long as it's all multiplication, then you can set each part equal to 0. So I get 3x equals 0, x plus 4 equals 0, x minus 4 equals 0. Now I need to solve these, and I should get the 3 answers I'm hoping for. Here I need to divide both sides by 3, and that gives me x equals 0. You are allowed to get 0 as an answer, so don't let that freak you out and then decide that you don't know anything. It can happen. Now here I need to move the 4 over, so I'm subtracting 4 from both sides, and I get x equals -4. Here I'm adding 4 to both sides, and I get x equal to 4. So my answers are 0, -4, and +4. I should be able to plug in any of these 3 numbers into right here and have it check out.